Hello everyone. Today it's a beautiful Saturday morning here in Norway, and I want to start to make some videos trying to learn Aiken. So we had an interview earlier with TX Pipe, and we talked a bit about Aiken and how it's actually the smart contract that's doing Fortuna, the proof of work concept contract that functions kind of like Bitcoin does. And yeah, that got me curious about Aiken, and what better way to do this than to record stumbling and falling. I have not rehearsed anything here. We'll just do everything live. So going to the website, it's aikenlang.org, and they have a playground, but we are going to do the get started part to actually install the compiler and toolkit for it. It looks fairly simple in Linux, so my plan here is to use Windows VSL, and it's quite easy to install. Just search some guides for that, like install Windows VSL, and then you have a fairly straightforward way to do it with command in PowerShell VSL install, and you need to have like virtualization activated and stuff like that. But yeah, you can just read the guide and then you can install VSL. Yeah, and with that we have Linux, we have Ubuntu, so in Windows VSL, and I will just get the Aiken long script, and it's fairly straightforward. Simply run Ike up. Oh, oh, because we need to source the environment first, so we do like this. And then we can do Ike up again. Well, that was fairly fast. And I guess maybe I should make the text a bit bigger so it's easier to follow. Let's see. Oh, I'm already sold. They have ASCII graphic on their interface, like beautiful. So yeah, that's doing the compiler itself, and that was very fast. And then you can do a language server. Configure. Oh, so you can do like command line with the language server and the plugin. And I wanted to do the plugin, so this you could get it here, or what you could do is like if you have Windows VSL installed, you can get it to simply run in your VSL installation. I mean, if you have the VS Code installed, you can then run it after in VSL, like this code dot, and it will start up an environment there. And then you can go to extensions. You just do Shift Control X, and then you search for Aiken, and then you install it. And then you're actually in your VSL folder. This is your folder there, and then you can code from there. It's fairly simple to install VS Code. You just go to Visual Studio Code, download for Windows, install it. So it's fairly straightforward. So we have that, then we can get started. Let's create a new project. So Aiken new. Oh, we need a new name. Let's test one. It's malformed. Oh no. So it has to have an owner. Let's try like that with May only contain lowercase letters numbers. Sure. Ooh, we have created a project. So product created, and it's test one owned by Aiken, and it has like a build file and a folder organization. Uh, Aiken projects divide their source code into two categories: library code and application code. Yeah, that makes sense. So that's usually how you do in coding. Like libraries are stuff you reuse, and application code is more like app specific. After compilation, the compiler generates a Plutus blueprint, Plutus JSON, which is an interoperable document that summarizes your project. Ooh. So I can build, you compile. One warning, you do not have any validators to build. Oh, because we have not. But we have a Plutus JSON now. And NEA is just like nice editor. You can install that with sudo apt install NEA. And it's just because I like using that editor. If you're wondering why I'm writing NEA Plutus. We could probably just code with the... Let's try this. Let's see if it goes into the visual. See there, ta-da! Okay. So every project has a preamble, I guess. The title, description, version number, and license. So Apache Tunnel, I guess that's like a fairly open source license. Not so into it, but I believe that's the case. So you can basically do whatever you want. Let's see what else. A product as a top level as Aiken Tomo, as its root containing metadata about the project as well as dependency required by it. Okay, let's look at our metadata Tomo. It's code Aiken Tomo. Let's see how it looks like. Okay, so if you have a GitHub repository, you will write it here. And what dependencies? So I guess as this is standard library, and maybe that's built in with the compiler, probably. And then that means you can use that for your scripts. You don't need to have that open anymore. Actually, let's just look what this Apache 2 license actually allows us to do. Explain. Let's get the short version. Open source permissive software license that ensures that end user are granted license to any patent that is covered by the software in question. So you can use it commercially. You can modify the source code and distribute it. And you can do, you have non-exclusive rights to patents and copyrights. Users are permitted to create copyright statement for their modified software source codes. Okay. I'm not that deeply into patent law, but looks like there's something in there. But definitely can be used commercially, and you can modify and distribute the code. So that's good. And I probably revealed how little programmer knowledge I have, and I don't know the full extent of the Apache 2 license. But yeah, that's why we're here. We're here to learn, so that's cool. So it has a prelude, contains a minimum set of functions, constructions, and modules available by default to all Aiken projects. Okay. So functions is some like reusable code that you can send some parameters to usually. Constructor is like to create some, for example, a data set, if I remember correctly. Uh, Modules, not so sure I remember fully. Oh, this will be fun. Um, but let's look at, you can find Aiken lang prelude at the bottom of this web. Okay, Aiken built in. Low level built-in circuits by Pluto's virtual machine. Okay, and I'm up to high level functions in standard library. Oh, so you could use standard library, or you can use this like Aiken built-in, and these are like low-level built-ins that you can use for the Pluto's virtual machine. And Aiken itself is already, oh, so that's the module basically. It's a set of types and functions. There you go, that's a module. So the Aiken module is done by default, and you don't need to import it as a dependency. It's always imported. Okay, so we actually have the compiler, we have the plugin, we have the code or code viewer we can use, VS Code, and it's connected to our VSL Ubuntu. And they will teach you how to EUTX. So, okay, this is more familiar grounds for me, so I will skip that part a bit. But this is very nice. I also can recommend, like, Cardano Foundation has a really cool crash course about EUTX, and explains it very well. Yeah, there's this is actually quite deep, quite good, and quite detailed about it. Okay. Oh wow, it really goes through everything, like types, variables. Cool. Uh, if anyone has done any type of hobby programming, this should be fairly familiar. Setting values, comparing values, stuff like that. Functions, pretty simple. Name, what parameters you do, the actual calculation in the bracket. Labeled arguments. Oh, well, that's nice. So it's like more readable. That's very user friendly. So you can label the variables more and get suggestions and then override it if you want. That's nice. Validators. Oh, I'm not so familiar with the term validator. What is a validator? Oh, validator. It seems to be a function, but it has to have some strict rules for a function. 2 or 3 arguments must be named. There may be 1 or 2 functions in a single block, but no more. Validators can take parameters which represent configuration elements. Ah. I have never tried Elixir, never tried whatever language that is, F hash. But pipes, yeah, you do piping in Linux, so but not seen it with those signs. It's cool. Function capturing. Oh my god, this is a lot to take in. I think probably I need to read this more carefully, and we just focus on the setup part of this. Oh, so let's skip all of the theory for now. and just make sure we are doing the setup. So we have done the installation, we have done the getting started, and what we would do next is to try to set up or pull some code. So the Aiken main repository, hello world. Let's try to see if we, I wonder if we have git installed in the VSL or not. Uh, Also, it's not a repository in itself. Let's just see how the tutorial says we should do this. First, let's create a new project. Okay, let's do that. So, and I guess the user is Aiken and the project is called Hello World, and then we'll enter that. Maybe the validators is a type of function that's part of the smart contract that validates something in a transaction. We will see. I'm really not familiar with the term validators in the coding. This will be interesting to learn. We'll use standard library for it, and this should be already included. So when we installed, by just pulling that script, it should be included. And let's see in the Aiken TOML, or just the code maybe. Yeah, it's the same. And so when we do Aiken check, we actually load the dependencies, so those modules. So let's try that. Aiken check. Fetched one package. Okay. Compile the standard library, I guess. That's nice to know. Let's write our first validator. That shouldn't take too long. It took like 0.03 seconds. Nice. Let's write our first validator. We're using like these, is it functions or libraries? Yes, libraries. I'm not sure. But the Blake to be, that's a form of hashing, I guess. Fairly, that's common in Cardano, using Blake to be. Transaction script context, so maybe scripts for transactions, credential, verification key, so probably for the transactions credentials. So interesting, it looks like they divide the library into different segments. So one is credentials. Okay, datum, I guess that's a form of data type. Redeemer, oh my god, I am so rusty in coding. What could a redeemer be? Oh, I need to Google that probably. With a validator, okay, so that's the function hello world. It takes the data, it takes the redeemer, takes a context from the script, produces a bool, and must say hello. The variable must say hello, is passed the redeemer message hello world. Must be signed. Okay, so I guess we're also signing it with the verification key. Then must say hello and must be signed. It's a parameter by verification key hash owner and a message. Remember that in UTX model, the datum is set when blocking funds in a contract and can be therefore be seen as configuration. Hello world is a very tradition in the coding world. This is in the legal world we have in Norway. Like, all cases are with pederos. It's still tradition to start with a hello world. Oh, so we just create this validators hello world. Okay, sure, let's do that. It's supposed to be. Let's paste this, and it seems the Aiken language server client could not connect connection to the server. Oh, so I guess we also need the language server to do this. Let's go back to the installation. Language server. Aiken LSP. If comes with a built-in language, if needed, configure a client with the follow configuration. Okay, let's try that. Hmm, not sure why it doesn't. Icon language server client could not create connection to the server. But why? It's already connected here and it should be installed. Icon language server client could not create. Sorry, launch server using command icon error spawn icon. Let's see if we can get some. Okay, so looks like this environment here is not connected to the icon. Hmm. Definitely at least the syntax is here. We'll try to figure that out. Uh, hmm. And we definitely have syntax highlighting, so at least we have that. Okay, let's go back to the. Let's go back to the hello world example. We have the code, and we just check the code. We need to be in the same folder or not? Let's see. Okay. So you need to be in the root folder to do that. I can check it and recognizes all of the subfolders, I guess. Okay, looks good. Let's try to build it. So this is basically compiling. What you're doing is making it into executable code. Ah, why? We have a validator. Oh, we did not save it maybe. Whoops. Let's see. Okay, there we go. So I can check. I can build. Okay, we have built. And it's actually following a standard, a ZIP 057 Bluetooth blueprints. Cool. It describes the contract and its binary interface. Oh, and we need to generate public private key pair. And we will use Lucid. That's a library for transactions, I guess. And credentials. And that's TypeScript, I think. Deno, if I'm correct, it was TypeScript. TS, TypeScript. Okay. And then we also need to have Deno installed. So I guess it's good we did some of this for the first video. Um, okay, let's. I think I already have Deno installed, but Deno install. Let's just quickly run to that. So again, it's just a bash script. Okay. Then, do I need to run the other directory to home bash? Okay. So if we do that, we have it as in our path, and then it's easier to run it. So let's do that. It should be in home folder, and we export at the end, and we already have Aiken there. Okay, we need to source it. That is just shorthand for home, if you're wondering. The sign. You could also just like do this. Um, yeah, so now we have Deno, and we needed that. I guess for Lucid. So it doesn't say where we should write this script. Uh, let's try to guess. I guess should be in the validators maybe. Where's the library? Oh, let's write our first script. Uh, uh, uh. Let's look into the repository how they do it there. Uh, let's find the one for Hello World. Okay. Oh, so the script is just in the main folder, I guess. Okay, then we know that. And for TypeScript, we recommend installing that. Yeah, it's a TypeScript then, I guess. We might need a account in Blockfrost. That's the both Node and it's a basically an API with nodes behind it. It's Marek, cool, very cool guy in the ecosystem running that. Faucet, usually for testnets, easy to get testnet ADA, and you can use an explorer to see how the contract is working, for example. But okay, so now we know that the credential TypeScript should be in the main folder, so we could just code and then generate cred. Then we have a TypeScript, and it doesn't recognize Deno, but we could probably install some form of extension for that. Actually, let's see if there is some extension. Deno. Okay. Then VS Code extension pack or the language server. Let's just try the language server. Okay. Probably would have to reload this, but let's just save it. Maybe we also need extension. 5 stars. More downloads. Okay, let's install it as well. Yeah, okay. Let's just reload it and see if that helps. Okay. Well, we'll have to figure out the demo extension in another video. But definitely it's recognizing TypeScript, but not the demo. But we have it, the contract, and then we can run this. Okay. Let's do that. Okay. If we actually created some addresses. Yay, we have a key and an address. That's cool. Wow, that was seriously quick. to, the integration is fantastic that you can so quickly just get Lucid with TypeScript, create this address. That's amazing. Wow. Um, who says developing on Cardano is hard? I am utterly newbie doing this now. And we just create an address. Okay. Um, then we need to have a faucet, and we have been using the testnet preview, so we need to get uh, either from that network. I actually don't have a node running on the preview testnet. I'm using preprod myself for ADA Nord Pro. Yes, I should also support the preview network maybe. Anyways, API keys if you want like a huge amount, but we are not doing that. Let's just see if we have some ADA. Success! So we are now very rich. You could probably even follow that in Cardano scan. Yeah, so we just hash the transaction hash. Takes a bit while before it's out. So usually it's, I mean, a block is every 20 seconds. And it takes a while to propagate. So let's say a minute or so. Oops. Oh, it doesn't like Cardano scan. You should fix when you have an empty search. You get a bad request on your preview. It's not yet there. Are we on the right? Yeah, we're on preview. Let's make sure we have that. And it's the preview tested, so it's fine. Should be. Okay, while we wait, let's just do something else in the meantime. Okay, so now we're setting up Lucid with the BlockFrost as a provider. Let's try that. Oh, so it has a built-in BlockFrost driver. Again, Marek from BlockFrost has done an excellent job, like creating libraries, APIs, everything you need to build and use BlockFrost. Then hello over the okay lock. Let's do that then. Code hello world lock. Save. What are we doing here? We're importing the different libraries like Lucid, BlockFrost. We're using TypeScript. That's why then the TS, and we're using Deno to compile with it. Seaboard, that's how data is represented usually in Cardano. It's a more efficient format than JSON in storage, and it's not human readable in default, but you can decode it to make it human readable. Okay, so I guess we're defining a constant that's this lucid, and this lucid is a way of doing things like a new block frost. Okay, so that's how we interact with the API. And here is the block frost API for preview that we're interacting with. And we need to have a block frost API key. So I guess we should get that from block frost. Should probably write that in the tutorial. Yeah. So I don't know if I have an actual account here. Let's see. Let's just sign in. Oh, I had one from mainnet a long time ago, I guess. Oh, you just see my API key. That's nice. I should probably delete that. Yeah, before it's misused by this video. Okay. um, yeah, they have a starter plan. And you can, let's go on preview. Let's just call this Aiken. Okay, do we have an API key we can use? Come on, give me an API key. There we go. Oh, that's the project ID is the API key, is it? Let's see. Okay, it's not fairly straightforward if that is the API key, but it looks like it. So SEBM, let's see if that's what it ends with. SEB, yeah, it looks like it's the API key. Okay, so we should then have this. You can define a new variable in the terminal by running in the same session, export, and then your API key. So let's do that. Block API key. Okay, now we have the API key. Next, we need to read the validator from the blueprint Protos we generated earlier. We also need to convert it to format that Lucid understand. It's done by serializing the validator and converting it to hexadecimal string as shown below. So this is also part of the code. Okay, so hello world is bigger than what we saw so far. Okay, and then now we can read our validator. We can make a first transaction to lock funds in the contract. Okay, we already have a public key. We have created it, so like that. Then let's see if this fails terrible or not. Uh-oh. Line 3819. Mhm. So it's getting the address details. It's failing when it's getting the payment credential hash. Why? And it's k.sk. I think it was named k.sk in our folder. Yeah. So why is it having a problem? Okay, let's look at the actual hello world lock. Could be a formatting issue, so let's do the raw file of it. Try to import it. Let's just see if it potentially is a formatting issue. No, can't convert undefined to a big int. So it's trying to convert a variable that's undefined to a big integer. Big int result k deposit. So the variable it's trying to convert is the result k deposit. And it cannot convert it because it's undefined. Maybe we need to do some typecasting, like meaning to make it into that format of a variable, like a big int. Not really sure how to proceed with this one. We have done this already. I can check. Hmm. Try to look at the code again. So where to begin? Oh, 38. The line 38 is in the block frost part of the that we import. At async file lowered hello world 1317. Oh. Is it failing to get the API key? Could that be it? Let's try. Make sure we have. Oh, there you go. My God, I had the wrong variable. So probably it was just failing to get the API. Definitely looks like it's trying to do a contract, contacting and interacting with the blockchain because of the wait time. This is cool. Okay, so that's what we have done. We have locked phones into the contract. Yay! And we locked a total of 1 test data into the contract. Let's see if we can actually see the transaction now. Yeah, okay. It just took forever, but the faucet gave us 10,000 testnet data, and we now have this transaction as well. Probably not yet there, yeah. But it's there on the blockchain, and it will be here on the preview on Cardano scan as well. Okay, I guess when you see that error, if you're doing this as well, just make sure to also export correctly the API key for Blockfrost for your project. And yeah, if you see here, probably we have a few requests, and we had actually, wow, 15 requests just for that. This cannot be true, or let's see. Yeah, it has 15 requests for doing that. Interesting. I'm not sure that's very. That's quite a lot of API requests just for a single transaction like that. But okay. Uh, so we have all of this. cool. We have this. Then we locked phones. Now we're going to unlock them. So let's make a new one. That's the unlock script, TypeScript. Hello world unlock TypeScript. We're getting our key. We're reading the Plutus that has the validator and everything. I really need to understand the validator concept. Likely it's with the smart contract. It's version 2 of Plutus. That's cool. And then we need the transaction identifier obtained when you ran the previous script. Okay. We already have this block frost API key, tx hash. We're passing it. That's the redeemer. Okay, cool. Okay. So let's pass it. And in our case, we have another transaction hash. This one. The block frost API should have more requests, and it does. Okay. We locked one ADA. Cool. And then we unlocked it again. See if we have. It's not yet there. Okay. Well, we're typing hello world in the transaction. Let's see where. No metadata to it. Maybe. Yeah, so when we unlock, we are creating extra data. That's where the hello world part comes in. Here. So in this transaction, whenever it arrives, we will have done a hello world. And that's a good place to end it there when we have that. But like to summarize, like what we needed. So there was a few steps we needed to set up Aiken for this example. You needed to install the script, and then you can do ike up. So first this, then ike up. Then you needed to source the environmental files, as we did the beginning here. Oh, it doesn't scroll up, but like the sourcing, like for example, let me go back here. So, and we exported some variables for the deno as well. So we installed the deno, and we had to have a block frost. Oh wow, 37 API requests just for that. Wow. Okay. Yeah, so you need the block frost. You remember to preview. You needed a faucet, and again in the preview testnet, you needed to export the block frost API. You needed to remember the transaction that you created with locking it, and then you unlock it, and here we go. And look here, we have a contract. This is my first actual smart contract. This is fun to have done. Okay. Okay. We used this many memory units and this many CPU steps. Okay. Is there no way to see the metadata if we have said hello earlier? Okay. Mm, should have also added the metadata with hello world. That would have been cool. Uh, but I guess we're writing this in Xcode then. Probably here somewhere. I'm just guessing wildly. Uh, this is our contract address. Oh, this is so cool. Okay. Huh. Well, cool. So yeah, summarizing: install VS Code, install Windows VSL, install Dano, install Aiken, get block frost. That's what you do to do it. And I hope you enjoyed me stumbling around with this. It was fun, and I hope to do more Aiken stuff later. Okay.